Okay, this is the video number 3 of the Sound Lab. In this video, I will explain what we're going to do in activity number 3. In activity number 3, we're going to observe beats and then we're going to measure the beat frequencies. We can observe beats when two waves which have similar amplitude and they are traveling in the same medium in the same direction, but they have slightly different frequencies. So when they add together to give the resultant wave, we will observe beats. In order to generate these two waves with slightly different frequencies, I'm going to use these two speakers, and you can see speakers are connected to the signal generators. So here I have two signal generators, they are identical. This is my signal generator 1G1 and this is my signal generator 2G2. So I can change the frequency of the signal here using this knob. I can change the amplitude of the signal. I'm going to keep the frequency of this signal generator at 256, and in signal generator 2 I'm going to change the frequency to get beats. Here's my sound sensor, and I'm going to use this sound sensor to detect the resultant sound wave, and this is connected to the analog input A of the 850 universal interface, and I can see the signal in here. This is the oscilloscope, so I'm going to see the signal here in the oscilloscope. Okay, now let's turn on one speaker. So I'm going to turn on one speaker and the frequency is 256, and so I have my sensor. I'm going to turn on the oscilloscope. 256 hertz frequency signal, and here I can see that signal. So I'm going to stop recording so I can capture that signal. And now I'm going to run the second speaker to make sure it's working. It's working. The frequency is 256, and again I can see the signal. I'm going to start recording. I have the signal and I can capture the signal. So this is the second signal generated by the G2, the signal generator G2. Okay, now I'm going to connect both speakers, and this is the resultant wave, and I'm going to decrease the frequency of the G2 generator to 250. Now you can hear the beats. Oscilloscope, you can see this pattern. I'm just changing the time axis, and these are called the beats. So I'm going to capture that signal. So I captured the signal. Now I can turn off the speakers. Now I'm going to measure the frequency of this resultant wave and the beat frequency. Okay, now I'm going to measure the beat frequency. To measure the beat frequency, this is what I have to do. I need to get the time value here and here, and this is period of the, this is the time axis, and this is the period of the beats. So if I know the period, then I can calculate the frequency. So let's get the time values at these 2 points. So I have points 118 seconds, and here I have point 449 seconds. Then you can calculate the period, which is 0.449 seconds minus 0.118 seconds. The reciprocal of that will give the frequency, beat frequency. I will show you how to get the frequency of this signal. In order to measure the frequency of this signal, we need to get the period of this signal. This is how I'm going to measure the period. So I'm going to count like 10 waves and get the period, average period of these 10 waves. So I'm going to start from here. So this is 1 to here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. Okay, so the time between the time between these two values is the 10 periods. The values are 192 and 152. So the difference is 10 periods, and in order to find the frequency, so you need to get the period and get the reciprocal of that. Okay, now I'm going to get the beat frequencies of these two frequencies. The frequency of the generator 1 is 256, the frequency of the generator 2 is 276, so the difference is 20 hertz. So I'm going to generate the sound waves. Now both speakers are working, and I'm going to record the wave. So this is the wave, so you can see the beats. So now I can capture this wave. So I captured that. Now I can turn off the speakers. Alright, so I'm going to calculate the beat frequency. To get the beat frequency, what we need to do is we need to get the time from here to here, that is the period of the beat. Then if you know the period, you can calculate the frequency. So let me get the values. So here it's the time value is 0.078 seconds, and here the second time value is, or the second data point I need to calculate the period is 0.178. So I can use my Excel sheet to calculate that. 0.078, this is 0.178, and I get the beat frequency, which is 10. Okay, now I'm going to calculate the frequency of this resultant wave. To do that, I have to get the period of one of these signals. So what I'm going to do is, to get more accurate value, I'm going to count 10 waves and get the period or the time for 10 periods, and then from there I'm going to calculate the frequency. So in the data table you will have all this data, so you can do the calculations.